Consider the following hypothesis test. Null hypothesis, mu equal to 18 versus alternative, mu not equal to 18. A sample of 48 provided a sample mean x bar of 17 and a sample standard deviation s of 4.5. Part A, compute the value of the test statistic, which will be a t-statistic in this case because we're not assuming a known population standard deviation. Plugging in the sample values into our formula, we obtain a value of minus 1.54 for our test statistic. Part B, use the t-distribution table to compute a range for the p-value. So we need the degrees of freedom, which is n-1 in this case, or 47. And then, because the critical values in the t-distribution table are positive, rather than looking at minus 1.54, we'll look at plus 1.54. So what we want to do is we want to use the t-distribution table, go down to 47 degrees of freedom, and then look along the values in that row and find two values that would lie either side of 1.54. And if we do that, we find that 1.300 would be to the left of 1.54 and 1.678 would be to the right of 1.54. And so therefore the tail area for 1.54 is going to lie in between the tail area for 1.300 and 1.678. And the tail area for 1.300 is 0.10, and the tail area for 1.678 is 0.05. So therefore the tail area for 1.54 will be in between 0.05 and 0.10. Because this is a two-tail test, we need to think about what's happening in the left tail as well, but because this whole distribution is symmetric about 0, all we need to do is multiply those values that we found for the right-hand tail by 2, and we will obtain a range for the p-value. So putting all this together, we find that the p-value lies in between 0.10 and 0.20, and the 0.10 comes from 2 times 0.05, the 0.05 being the tail area to the right of 1.678, or equivalently minus 1.678, and 0.20 comes from 2 times 0.10, 0.10 being the tail area to the right of 1.300, or equivalently to the left of minus 1.300. Part C, at alpha equal 0.05, what is our conclusion? So we know that the p-value lies between 0.10 and 0.20, so it's certainly bigger than 0.10 and even more certainly bigger than 0.05, which is our significance level, and so therefore we fail to reject the null in favor of the alternative. So there's no evidence that mu is not equal to 18. And part D, what is the rejection rule using the critical value, and what is our conclusion? So the rejection region in this case, the critical value in the t-distribution table 2.012 has a tail area of 0.025, and so putting that together with the left tail of minus 2.012, we would have our significance level alpha 0.05. So the rejection region is any test statistic either less than minus 2.012 or greater than plus 2.012. And since our t-statistic minus 1.54 does not lie in the rejection region, it lies in between those two critical values, then we fail to reject the null hypothesis in favor of the alternative, and again there's no evidence that mu is not equal to 18.